Hi everybody, I hope you had a nice weekend. Make it a magical Monday. All right, so your homework for today is going to be a summary for the EQ and then an IXL, which is super easy. IXL Math 8 F11. Quick notice about the placement test. Please read the notice about the placement test. This is not coming from me. This is coming from the district, and it has to do with your high school placement. Excuse me. And then go ahead and take out your notebook. We're going to learn about taking power to a power today. Okay, power to a power. And again, I'm going to do this as fast as possible. Please pause it everywhere you need to. That way, if you need to replay it because you forget something, you can go through it quickly. Okay, here's your essential question. Only write down what is in black. Explain why the rule for raising a power to a power works using this example. You can also write down the example. X to the fourth power, and then that whole thing is raised to the second power. What's in blue is what I want you to keep in mind when you do your summary. We'll talk about that at the end. Okay, so here is an example of what we're talking about when we have a power to a power. We have x to the second power, and then we're actually taking that whole thing. We're using that as our base, and we're raising that to the fifth power. So if we're going to do that, let's get some blue here. That's basically telling us that we're taking what to the fifth power? Okay, x to the second. So x to the second times 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 x to the second. Well, we know that would be, for each x to the second, we've got two x's, right? X times 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 x. So when you're all done counting up how many times you used x as a factor, you used it 10 times. Take a look at the exponent you finished with, and take a look at the exponents you started with, and start thinking about what the shortcut might be. And our shortcut's going to be our rule. Okay, let's move on. Okay, here's another one. 4 to the second power, and then the whole thing is raised to the third power. So that's telling us that our base is 4 to the second. And we're using that as a factor 3 times. And then if we're going to multiply that out, it's just coincidence that's to the second here. Now we have, within that, there was a base, and the base is 4. And it's telling us to use it as a factor twice. So each one of those is telling us to use 4 as a factor twice. So we end up with 4 to the 6th power. So again, take a look at the exponent we ended with, and then take a look at the exponents that were in the original problem. What do you notice? Do you think you have what is happening there? Do you think you know what the shortcut would be? Pause for a minute and think about it. Okay, so let's go take a look. So if we've got 2 and 3, how would we get to 6? Well, 2 times 3 makes 6. If we go back and look at the previous problem, how can we use 2 and 5 to get to 10? Well, 2 times 5 makes 10. And so our shortcut, or our rule, is when you raise a power to a power, just multiply the exponents. Make sure you get this down. You're going to use this again in your summary. Be ready to use that again in your summary. Those summaries need to clearly state the rule. Okay, let's try this. I'm going to switch back to blue. Okay, so you can see where this is super easy. So if you have x to the 7th and the whole thing is taken to the 5th power, we're just going to multiply those two exponents together. So you're going to get x to the 35th power. On the next one, even though you have a negative exponent, that's fine. You're still going to just multiply those two exponents together. So you're going to, 2 is your base, and you get 2 to the negative 48th power. Next one, you have 10 to the 9th and the whole thing is raised to the 7th, you're just going to multiply those two exponents. So we get 10 as our base, and it's raised to the 63rd power. That's it. So I want to emphasize, we are not in we're not looking at multiplication problems here. We're looking at power to a power problems where we have something with an exponent on it, like this, 10 to the 9th, and then we're taking that whole thing and raising it to an exponent. Okay, so it's not a multiplication problem, it's a power to a power problem. We multiply the exponents in this case. Okay, if there's more than one base being raised to a power, just distribute the power that's outside the parentheses. So in this case, we've got 2, and we have y. 2 is its own base. Think about it. What power would it have if we were to give it a power, since it's not showing a power right now? Okay, so anything without a power you can give to the first power. So you're going to multiply this 4 times each of the powers. So you're going to get 2 to the 1 times 4 power. 1 times 4 is 4. And you're going to get y to the 3 times 4 power, and that's to the 12th. Sometimes with something like this, you'll see it worked out as well. You'll see the number part worked out, because we could work that number part out. So you'd have 2 times 2 times 2 times 2, and then y to the 12th. Well, that's going to give us 16 when you're all done, y to the 12th. Okay, over here on the next one, again, we have two bases. We have the x, and its exponent is 5. We have the y, and its exponent is 9. And then that whole thing is being raised to the 3rd power. So we're going to distribute that power outside to each of the powers inside. So you're going to get x to the 5 times 3 makes 15, times y to the 9 times 3 makes 27th. So that's it. Next one, we have how many bases here? 1, 2, 3, 4. The 3, the w, the x, and the y. 3 does not have a power on it, so let's give it a power. If it doesn't have a power, we can give it the power of 1. So let's go ahead and multiply that outside power times each of the inside powers. So you're going to get 3 to the 1 times 2 makes 2. And then w to the 8 times 2 makes 16. And then x to the negative 2 times 2 makes negative 4. And y to the 4 times 2 makes 8. And if we did worked out the 3 to the 2nd power, that's 3 times 3. So that's 9. W to the 16th. X to the negative 4. Y to the 8th. That should be an 8 there. All right, one other fancy way to do this, just a little extra for experts. If you wanted to get rid of all and make it all with positive exponents, you could bump this to the bottom. So this could be 9 w to the 16th, y to the 8th, all over x to the 4th. Anyway, a little extra for experts. Okay, now pause, and you go ahead and try the problems here, and then turn it back on and see if you were correct. Okay, so you've tried those problems. Let's take a look at this one. You're going to have 10 to the 5 times 6 power, which is going to give you 10 to the 30th. For number 10, you're going to have 3 to the negative 8 times 4 power, which is going to give us to the negative 32nd power. And then in this last one, you have 3 bases, the 5, the x, and the y. 5 doesn't have a power on it. Give it a power. It's going to be 1. And then distribute that 6. Distributing is just multiplication after all. So you're going to have 5 to the 6th power, because 1 times 6 makes 6. You're going to have x to the 12th power, because 2 times 6 is 12. You're going to have y to the 24th power, because 4 times 6 is 24. All right, so to wrap up, when you do your essential question, remember, you're going to use this example. You're going to work it out in factored form. So you're going to work out the examples 2 ways. In factored form, like we did with number 1 and 2 on these notes. And then also using the rule. And when you can show that they come out to the same answer, you are providing some evidence that the rule works. So we're not trying to ask whether the rule works or not. It does. We're trying to show why it works. So I want you to explain that, oh, since they're both coming out the same, this means the rule works. And then go ahead and state what the rule is. State it clearly. It's that thing that we have it, remember? We